Okay. Topic for this video is going to be permutations and combinations. And what we're going to be mainly looking at here is just how to calculate these things. How are permutations and combinations calculated? Now, to get things started, we got to start thinking about how many different ways we can do things, because that's kind of what a permutation and combination is. And we're going to start off with something basic before we get into those. The multiplication principle of counting. That says that if a task consists of X selections for the first choice, Y for the second, and Z selections for the third choice, and so on, then the task can be done in a total number of ways equal to X times Y times Z. So let's see what this really means here. Example 1 says a new tablet has a small or large screen option. Okay, so that's kind of like two different ways. 3 different memory sizes, and both a black cover or a white cover. How many different total options are there? Well, we have 2 options for the screen. We have 3 different options for the memory sizes, and we have 2 options for the covers. So 2 times 3 times 2, oops, meant to do that in blue, should give us our total number of ways of 12. There are 12 different options here. Example 2 is talking about a burrito restaurant. We've got 3 different burrito sizes, small, medium, and large probably. 5 different meat options, 2 different rice options, 4 different salsas. Oh my goodness, so many options. A choice of cheese or not, and an option of sour cream or not. So many different options. How many different types of burritos could you get? Okay, well, we got 3 sizes, 5 meat options, 2 rice options, 4 salsas, cheese or not, that's 2 different things, and sour cream or not. So I need to get all of those options and multiply them all together. I'm doing 3 times 5 times 2 times 4 times 2 times 2. And that is 480 burritos. Wow, a lot of burritos. That's not even taking into consideration maybe getting 2 different meat options or 2 different salsas on there. But if we're just picking one of each, 480 different ways we could do it. Example 3 says Adrian has 5 different shirts he wants to wear from Monday through Friday. He will wear a different shirt each day. How many different ways could this be done? Okay, this one's a little bit different. Well, let's just consider how many different shirts he could wear on Monday. On Monday, since he hasn't worn any yet, he has 5 different options. That is for Monday. Then for Tuesday, he's down to 4 options, right? Because he can't wear the same one twice. Then for Wednesday, he's got 3 options. For Thursday, oops, I almost wrote 4 again. For Thursday, he's back to 2 options. And then on Friday, he only has 1 option left. So that's how many different options we have for each day. 5 times 4 times 3 times 2 times 1 is 120 ways. Cool. Now, what we just did there, 5 times 4 times 3 times 2 times 1, that actually has a unique mathematical name. We're going to see that on the inside. The inside says factorial with this exclamation point. This is cool. Now, what is a factorial? A factorial is the product of all positive integers less than or equal to a given integer. All right, so n factorial, where n could be any number, would be equal to n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. So imagine what we did on the last page, 5 factorial. That is equal to 5 times 5 minus 1, which is 4, times 5 minus 2, which was 3, times 5 minus 3, which was 2, all the way down to 1. So when you're taking the factorial of something, you're multiplying it times every number below it, all the way until you get to 1. Now, your calculator can do that for you, That exclamation point mathematically means factorial, and your calculator will do it for you. Okay? So that's going to come in handy with our formulas for these next ones. We're going to be talking about a permutation now. A permutation is a certain arrangement of a set of values. If you have R objects that you are going to arrange from a set of N objects. So let's say you've got 10 things and you want to arrange 4 of them. Then your R would be 4 and your N would be 10 because you got 10 total things. Oops. And we got a formula for this utilizing the factorial. So on the top, you are going to put the total number of things that you are choosing from. So big number up top, N factorial, divided by N minus R factorial. And remember, R is the amount that you are choosing. Okay? Now, permutations are where order matters. You are arranging things in a specific order. All right? So let's look at example 1 here and let's give this thing a shot. It says there's 10 movies that Emily is interested in watching, but she only has time to watch 5 of them. How many different ways can she arrange her viewing experience? So she wants to kind of pick one movie to watch first, one for second, one for third, right? The order of this matters. She's arranging a viewing experience. But you can only watch 5 out of the 10. So in this case, we are going to do 10p5. We are choosing 5 movies out of 10, right? So this would be 10 factorial over 10 minus 5 factorial. Leave the 10 factorial alone. And what's 10 minus 5? Well, it's 5 factorial. So that's what I'm going to type into my calculator here. 10 factorial divided by 5 factorial. And that would give me 30,240 different ways. A lot of different ways. You believe it? That's pretty crazy. All right, example 2. There's 12 students competing for first, second, and third in a competition. How many different ways can this occur? So there are 12 people in this competition, and we care about first, second, and third. So we care about arranging 3 of them, right? So this would be 12 factorial over 12 minus 3 factorial. Once again, order matters here because somebody getting first is much different than them getting third. So this would be 12 factorial over 12 minus 3, we know is 9 factorial. So 12 factorial over 9 factorial. That's giving me 1,320 different ways. Example 6, a new class president and vice president are being elected from 6 candidates. How many different ways can this occur? Well, we got 6 candidates, so that's my big number. And how many people are we picking? Just a president and a vice president, so that's just 2. So this would be 6 factorial over 6 minus 2 factorial. 6 minus 2 is 4 factorial. So 6 factorial over 2 factorial is, over 4 factorial. I typed in 2. That is 30 different ways. So permutations are where order matters. There's going to be a first thing. There's going to be a second thing. There's going to be a third thing. Or there's going to be a president and a vice president, right? We have unique roles, unique positions. First, second, and third place in that competition, right? The order matters for permutations. For combinations, order does not matter. So a combination is just a grouping of a set of values. We're just throwing things in a group. It doesn't necessarily matter who's first, who's second. You're just in the group or you're not in the group. And for this formula, it's going to look similar. We're still going to be choosing R things from a group of N things. Okay, the only difference in this formula is you're going to notice that there's an extra R factorial on the bottom of the denominator there. So let's see some examples here. A pizza restaurant has 8 different toppings and you're going to choose 3 of them. How many ways can this be done? Well, this is definitely going to be a combination because it doesn't matter which order you pick your toppings, right? They're all just going on the pizza. They're all in the group of toppings on your pizza. There's not a first topping, a second topping, right? They're just toppings. They just go on the pizza. So we are going to be choosing from 8 toppings. We're going to be picking 3 of them. So this is going to be 8 factorial over 3 factorial parentheses 8 minus 3 factorial. So this would be 8 factorial over 3 factorial. 8 minus 3 is 5 factorial. And that's going to be what I'm typing in my calculator here. So 8 factorial over 3 factorial, 5 factorial. Gives me 56 ways. For example 2, we're choosing 5 to be in a group out of 25 total students. So 25 C5, because just as we're just choosing them to be in a group, right? There's not a leader of this group or anything like that. They're just picking to be in a group. Everybody's going in this group together. So this would be 25 factorial over 5 factorial, 25 minus 5 factorial. This would be 25 factorial over 5 factorial. 25 minus 5 is 20 factorial. Let me type that in there. 25 factorial over 5 factorial times 20 factorial. We're getting 53,130 different ways. And lastly, we got a basketball team with 10 players. We're choosing 5 of them to be in the starting line. So we're choosing which 5 are going to be starting out on that court. So we've got 10 to choose from. We're picking 5. So this would be 10 factorial over 5 factorial times 10 minus 5 factorial. That would be 10 factorial over 5 factorial times 5 factorial, right? 10 minus 5 is 5. Let's type that in there. 10 factorial over 5 factorial times 5 factorial. I'm getting 252 different ways. Okay, your turn to try some questions out. You're going to decide if it's a permutation or combination and then calculate the answer. Or, I guess, a multiplication principle of counting. It could be one of those. So you got to decide which type of formula to use and give it a shot. Come back when you're ready to check. All right, example 1's ordering a 2-topping sundae from an ice cream stand. 10 toppings are offered. How many ways can this be done? This is a combination. Since these toppings are just going on the sundae, not a specific order or anything. Order matters is going to be when we're doing, of course, that's going to be when we're doing a permutation. So this should be 10 factorial over 2 factorial times 10 minus 2 factorial. It's 10 factorial over 2 factorial, 8 factorial. And let me see what I get here. I'm looking at 45 ways. Headphones come in 5 different colors, noise canceling or not, in 3 different cases. How many different options are there? This is multiplication principle of counting. Multiplication principle of counting, MPC here. And that should be 5 times 2 times 3. That is 30 options. 6 different people in the final round of a competition. How many different ways can the gold, silver, and bronze medals be awarded? That's a permutation because we've got unique positions, right? The order does matter. Gold, silver, bronze. Those are unique spots. It's got to be a permutation. So this is going to be a 6p3, 6 factorial over 6 minus 3 factorial, which would be 6 factorial over 3 factorial. Let me see what I get here. Looking at 120 ways. How many different ways can 7 people be arranged in a line? This is a multiplication principle of counting because we've got 7 options for the first, 6 for the second, and so on down the line. Let's see what we get. Another way of writing that would just be 7 factorial, which is 5,040 ways. For number 5, we're packing a suitcase for a trip, but we only have room for 5 of my favorite shirts. If you have 8 shirts you're choosing from, how many ways can this be done? Well, we're just throwing these shirts in a suitcase, right? So that's got to be a combination. This should be 8C5. It's 8 factorial over 5 factorial times 8 minus 5 factorial. That's 8 factorial over 5 factorial times 3 factorial. 8 minus 5 is 3. And let's see here. We're looking at 56 ways. All right, hopefully that went well, and that's going to wrap this video up.